So, a quick recap of what we have discussed as part of propositional logic. Then we will get into the details about the predicate logic. So, proposition is an assertion or a declarative statement which is taking the truth value true or false. Then we introduced proportional variables as our focus is on understanding what is the truth value of the statement, and given a logical argument, how do we represent with the help of proportional variables subsequently prove that a given argument is true or false. So to extract the essence, we brought in the first level of abstraction, which is proportional variables. And then to evaluate an argument, we will convert a given argument into collection of proportional variables with appropriate operators. For example, logical and, or, and the implication operator, using which we will convert the given argument into a formal expression involving proportional variables and connectives. Then, as part of simplification process, we started using well-known implications. And for example, P and P imply Q is Q. And when you have something like P plus circle Q, which is XOR Q, we said that's precisely equivalent to negation of P biconditional Q. And so we will use well-known implications and equivalences to simplify the given argument. And things work very well, but there are constraints. There are constraints. For example, if you look at examples like this, boys are good, some boys are good, all boys are good, at least 3 boys are good. As far as propositional logic is concerned, all of them are propositions. We simply say this one is P proportional variable Q and so on. And if you look at this definition or this notation, it doesn't express the fact that some boys are good, some boys are good, all in all boys are good, at least 3 in at least 3 boys are good. But this is something we need when we prove a logical argument with respect to some specific phrase like at least 3, all, some, and so on. So what we want is we want to increase the expressive power of propositional logic, and we bring in the next item, which is called predicate logic, which is also called first order logic in the literature. And propositional logic, we call it as zeroth order logic. And propositional logic or zeroth order logic is only a special case of first order logic. So, as part of predicate logic, we bring in something called predicates and quantifiers. With the help of quantifier, we quantify some, all, at least 3, and so on. With the help of predicate, we express the characteristic about a boy, the property about so and so item. For example, good is a characteristic, so something like that. So we don't simply say this one is P. Instead, we give importance to the element or the item, and we also talk about the property of that element, property of that item, or the characteristic of that item. So the quantifier will tell you how many are actually participating in the discussion as part of the context under discussion, and the predicate will tell you the property about the element or the characteristic about the element. So to appreciate this further, let's look at a couple of case studies, for example this itself in detail, and so that you can appreciate what kind of predicate we are interested in, what kind of quantifiers we are interested in as part of first order logic. So we talk about two quantifiers. One is existential quantifier. The another one is universal quantifier. The notation is we say there exist x. This notation is for all x. So to talk about existential quantifier and universal quantifier, we need something called universe of discourse. We call it as UOD. And this is also known as domain or the underlying set. So underlying set using which we talk about the quantifiers. Okay. So let's look at UOD or domain. It could be examples, it could be set of people, it could be set of students, and it could be set of things, it could be set of books, or it could be well-known set such as natural numbers or all that. So we work with a set. That set could be well-known natural number set or real number set, or it could be a specific set according to the context we choose. It could be set of people, it could be set of students, it could be set of things, living things, non-living things. It includes both. And it could be set of books and so on. So fixing this set, then we talk about the elements of the set. So for example, the set of students, you will have something like S1, S2, all that. We are interested in talking about S1, S2. We want to know the property or the predicate or the characteristic about S1, S2 and so on. So as part of predicate logic, our focus is on understanding what is our underlying UOD or universe of discourse or domain of interest or the underlying set. Then we are also interested in the property or the predicate about the elements. And what is S1? Is S1 good? Is S1 bad? Is S1 having ICGPA? Things like that. So we want to talk about some predicates, characteristic, property of each of the elements. And this way I can talk about statements such as at least 3 boys are good, all boys are good, some boys are good, and so on. So having defined universe of discourse and the quantifiers, let's get into some specific predicates. With that, we will see how to express these statements. Okay. For example, I define the following predicates. So I define a predicate called boy of x, which means x is a boy. Okay. So I define something called say good of x, which means x is good. Where do this x come from? X come from the underlying set or the universe of discourse. So x belongs to UOD. We talk about two predicates, for example something called boy of x, which means x is a boy, and something called good of x, which means x is good. So fixing one UOD, we define predicates like this. Next we shall see how to express statements of this type. So consider the statement, some boys are good. What I will do is the following. So let me first fix UOD. So that could be set of students. Okay. Now you have set of students, so something like this. So you have S1, S2, like this. And some students are boys, some students are girls, and we want to express this. Then I define these predicates. I say boy of X or B of X. So boy of X, or just for my convenience I write B of X, which means X is a boy. Then I define something called good of X, or say G of X, which means X is good. Okay. Now I will make use of quantifiers. I will write FOL for this. So the first order logical expression using UOD predicates, we will define now. If you see from ZOL, you will say this is a proposition. Simply say P. That's it. So proportional logic associates a proportional variable, which means you get P for this. Let's look at FOL. It says sum. And when I say existential quantifier, so meaning of this, meaning in English, the natural language, there exist X or some X or at least one X. So they all mean one, and the notation is there exist X. When I say there exist X satisfying some property, and the notation is this. If I say some X satisfy the property, the notation is this. At least one X satisfy the property, the notation is this. So in first order logic, we use there exist X. In natural language like English, we may come across three different ways of using this or expressing this. So in English, if you say there exists X, the corresponding logical notation is this. In English, if you say some X satisfies some property, the notation is this. At least one X satisfies this, the notation is this. Okay, I hope it's clear. So statement says some boys are good. So notation is there exists X. Where do they come from? X come from this. So at this point in time, you know there exists a student. Now you talk about X. And the X says he is a boy. So X says X is a boy and he is good. That's all. So the first order logic for this statement is here. There exists X. Why am I using there exists? Because of some. And where do this X come from? X come from set of students. Then I want to bring in the property of this predicate or characteristics about X. So X is a boy. Not just that, and x is also good. So if you see this carefully, we use predicates and quantify elements, specific elements, for example in this case x. And just like the way we used to do it in proportional logic, we use logical operator and connect things. So remember, once you take a specific x, for example in this case is this. So for a specific x, for example, so x with say roll number COE 19 B001. So you will say COE 19 B001 as a boy and he is good. Okay. So for a specific x, B of x is a proposition. Suppose I say COE 19 B001 is good, and I cannot use existential quantifier or universal quantifier because it's with respect to a specific person. So you say COE 19 B001 is a good boy. Okay. And if you look at this statement, this is clearly a proposition. This one is clearly a proposition. So what is this telling you? The moment you instantiate a predicate using a specific x, the predicate becomes a proposition. So for a fixed x or a specific x, b of x is a proposition. Similarly, g of x is a proposition. Correct? So you vary x. So for a fixed x, first order logic FOL becomes ZOL, which means the predicate becomes a proposition. Put it in other words, FOL is a collection of ZOL, or you can see it this way: predicate logic is a collection of proportional logic. So you talk about this with respect to COE 19 B001, COE 19 B002, and so on up to say 65. So you talk with respect to each of them, then it becomes this becomes a proposition, this becomes a proposition, and so on. You talk as a whole, you talk as a group, you talk as a set, then you bring in quantifiers, you bring in predicates, it becomes a first order logic. It becomes predicate logic. So this says at least one element in the universe of discourse is a boy and good. Some meaning at least one. So some elements from this are good. Just now we have seen, although it is a first order logic or a predicate logic, this is actually a collection of zeroth order logic or propositions. So at least one element, this is saying at least one X belonging to UOD is a boy and good. Correct? So when we say there exists X, some predicate, okay, some predicate, say this, let me call it as some predicate, say P of X. When we say there exists P of X, and this is precisely what this says. P of S1 is true or P of S2 is true, and so on up to P of so many elements are there. So it could be no really big set. I say P of Sn is true. Okay, there exists X, P of X. It may be the case that all are true, maybe all are boys, there are no girls in the set. Or it could be the case that there are n elements, some 10 elements are true and rest of them are false. And some of them may be boys but they are not good, and some of them they are not even boys, and the rest are boys and good. So it only says at least one. It may be the case that S1 is a boy and good, it may be the case that S2 is a boy and good, and something from here. So now when you instantiate with respect to specific one, so P of S1 is a proposition. For example, S1 is COE19 B001. When you instantiate with respect to P of S2, that's a proposition, and so on. Okay, so one can also write for all X, just like the way we have seen there exists X, one can also write for all X in the similar fashion. So we will see some more examples on existential quantifier and universal quantifier, and as always some insights into these quantifiers. It is that insight that will give you some more information about the predicate logic and what more one can do in the field of logic, and how powerful they are when it comes to expressing the statements and subsequently proving logical arguments, which we shall see now.